Hello students, I'm going to now talk about the entropy calculations. As you know, the entropy is a measure of the strength of the password. Okay, so it is represented as the number of bits. Okay, and basically indicating what is the complexity involved in cracking a password or finding the password using a brute force approach. Okay, so it depends on the size of the symbol set, which is basically the number of symbols that you can choose from, and the length of the password, which is the number of symbols that could be part of your password. So if you were to do a brute force approach of finding your password, then the number of passwords that you have to um, try at the worst case is going to be what? It's going to be n raised to l. Okay, so this is the number of passwords that you have to try at the worst case. So all the entropy captures is representing this as a logarithm to the base 2 so that you can get it in terms of the number of bits. Okay, so now again from the property of logarithms, I can say log n raised to l to the base 2 is, I can bring this l over here and say l times log n to the base 2. Okay, so this is just from the property of logarithms. So now I can say h over l is going to be log n to the base 2. Okay, so now when you look at this expression, it is just a function of the number of symbols that you can choose from, which is the size of the symbol set. Okay, so we refer to this h over l as the entropy per symbol. Okay, and it is a measure of the strength of a symbol set. So again, the larger the value of log n to the base 2, the larger is the entropy per symbol. Okay, so which means if you want to choose a password of the desired entropy from a symbol set, once you know the entropy per symbol and the desired strength you want, then you can find the length of your password. So from this, again, from this expression, I can say let me copy this over here. I can say L is going to be h over log n to the base 2, and since the length of the password cannot be has to be an integer, it cannot be a real number, we normally do a seal of it so that you round it basically to the next largest integer. Okay, so this is kind of formula for the length of the password. And if you notice in the slides, we have something like this, right? So this h over l basically comes from here. You know, this h over l is log n to the base 2. So if you have say a targeted entropy, okay, so if you have something to achieve as a desired entropy, then I can put it as a targeted entropy, and the h over l over here is basically from your symbol set, because you see it depends only on log n to the base 2, right? So that's why you say it is basically only a function of the symbol set. Okay, so let's do a couple of problems that we have in the question bank. Let's do number 7. We want to calculate the number of symbols that could be part of a password. So which means you want to find the length of a password so that you can have an entropy of 32 bits, and the password is randomly chosen from a symbol set of count 128 symbols. So in this problem's question 7, you're basically given the targeted entropy that you want, which is going to be 32 bits, and the symbol count, the size of your symbol set, is going to be 128 symbols, right? So once you're given this, you can find log n to the base 2, right? So log n to the base 2 is going to be log of 128 to the base 2, which is 7, right? Because I can write 128 as what? 2 raised to 7. So let's see. So this I can write it as 7 times log 2 to the base 2. This is a property that everyone is supposed to know from logarithms also, so that I can simplify this, and this is equal to 7. Right? So your length is going to be basically this, where you have now 128. So your targeted entropy is going to be 32 divided by the log n to the base 2, which is going to be 7. So that's going to be 5. You divide 32 over 7, you get 4 point something, and you round it, that's 5, right? So now let's do number 8. So here we want to calculate the number of symbols that should be part of your password. It's again the password length, so that you can have a desired entropy of 64 bits, and the number of entropy bits per symbol of the password is 3.5. So again, going back to what we discussed, the number of symbols that could be part of your password is L. So length of the password, that's what you want to find. The size of the symbol set is not given here, but what is given here is the number of entropy bits per symbol of the password, which means you are given basically this log n to the base 2. So n is not given, log n to the base 2 is given. Okay, so entropy per symbol is given. So you want to find the length of the password. So basically you have to now apply this formula, right? So this is entropy per symbol, this is the desired entropy. So so the length of the password, so again from this formula, right? So that's going to be so what you want, the desired entropy 64 bits, and the entropy per symbol in the password is going to be 3.5. So you basically do a 64 divided by 3.5, 18 point something, so that comes out to be 19 symbols. So this is the length of your password. Okay.